Hey, how you doing? It is me, John Park, and welcome to John Park's workshop, just like the sign there says. I'm going to switch that camera. Hey, I've got a fun show in store for us today, so thank you for stopping by to check it out. I am able to check out the chat over on YouTube as well as Discord today. I got that working. I think I've got that working even over on my workbench, so that'll be good. So, the topic today is a Morse code transmitter and keying paddle made using some common household items and a Gemma M0 as the transmitter. So, let's actually have a look for a second at the new guide that I just put up, because I think this is going to give you an idea of what we're making today. I think this guide has just gone live, so let me set up a little screen share, if you don't mind, using a browser window. So let's go and bear with me. Let's see, is that going to be the right one? Maybe that one. Yeah. Ooh, looking good. Okay, let me shoot that over to you. And I'm going to rearrange this. So, by the way, I said yesterday I might try broadcasting in 1080p today. I did not do that. I've got a new setup, and I didn't want to risk adjusting too many things all at once. So, not doing that. But hopefully you'll notice I've got a bit better frame rate on this camera today than I have in the past. So, let me move this over here, and you can see what we're working with is going to be some clothespins to act as a keying paddle. We're going to use a Gemma M0 as our AM transmitter. I'll talk about that in a second, because you're probably thinking, wait, what? Gemma M0 doesn't have a radio built into it. Well, it sort of does, thanks to the sneaky trickery of one Philip Burgess, Adafruit's own Philip Burgess, Paint Your Dragon. Hey, Imagination of Form, I noticed in the chat over on YouTube said, not sure that we can see 1080p. Last night, actually, Phil and Lamore broadcast in 1080p, and some people were saying that the text was much clearer when they were broadcasting things that had text in them. So I think that is probably one area where you'll see a difference. Why is my channel dead? I don't know. Is it not broadcasting? How are we all here if it's dead? This is an interesting question, Tomas. I hope we're still broadcasting. Looks like we are. So you can see here we've got a Gemma M0, and I've got some connections running to the paddle. We'll talk about that. As well as a little arrangement of nails and rubber bands and things to make this double action switch. Now, I want to actually jump into, for a second, some stuff about Morse code. For those who are familiar, this will be old hat, but if you're not familiar with the way Morse code works, first of all, Morse code is a way of sending messages using usually audible clicks or tones, but can also be done with light. And it is international. It's internationally recognized as a form of communication. So it's used in ships and airplanes and cool spy kind of stuff. So this image I have here actually came from Wikipedia, and what it talks about is actually something we care about if we're building Morse transmission systems. A little while ago I built an escape room puzzle type of guide for Adafruit that was a deck of cards that can tell when it is dropped, and then it emits a message in Morse code. So in that one, I investigated this a little bit and found that there's actually a relationship between the elements in Morse code. So there are two types of tones or durations, which are a dot, which is short, and a dash, which is long. Whatever your unit of measurement or your duration of that first one, the dot is, and what I'm using in this sketch, this Arduino sketch that I've written, is a 100 millisecond duration for that dot. Then a dash is actually 3 times the length of that dot duration. The inter-element, so a dot or a dash, those are called elements. The inter-element spacing, so kind of the rest or the pause between them, is also the length of one dot. And then so for example, if you're saying the letter S, it would be dit, dit, dit. So that timing versus the O for SOS, the O is da, 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 so it's longer. And then there's a spacing between letters, which is also, I believe, 3 times the length of a dot. So it's dit, 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 da, 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 dit, dit, dit. That little spacing is between letters. And then there's a different spacing between words, which I believe is 7. I'm going to click this actually, make it big. You can see here, it says at the top, length of the dot is a unit, dash is 3, space between those elements is a unit, between letters is 3, and between words is 7 units. So knowing that, what I've done, okay, so you're probably asking, well, why are we going into this, right? Typically we talk about a Morse code keyer as something like this image that you see here. So this is a traditional straight keyer, and with a straight keyer you essentially have one switch that you're closing. It's a contact switch, and so if you're sending that SOS, you'd go, right, and it would go dit, 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 da, 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 dit, dit, dit. So you're responsible for all of the timings, which is very cool, and people who get good at it are amazing. I don't really know Morse code, and I'm not really good at it, so I'm not a good example, but I know enough to be dangerous and to talk you through it and to build this project. The type of keyer that we're going to make, and the reason I'm talking about wanting to know sort of programmatically what these timings are all about, is a type of keyer that is called a paddle keyer. And there are actually 2 types of paddle keyers. If we go back here to the guide, here is I believe this is an iambic. So there are iambic paddles and there are bug paddles, and I don't know the differences between those well enough. I know a couple of their differences, but I won't characterize them. The thing with the paddle keyers, though, is that there's actually 2 different directions that you can move or touch in the case of modern ones where it's just a capacitive touch. You can move. So if we use our index finger going from right to left towards that paddle, if we're right-handed, that's going to give us a dash. If we go from left to right, that's going to give us a dot, which means it doesn't matter how long you touch it, it automatically takes care of the timing of that dash. In one type of keyer, the bug type of keyer, you're responsible for dash repeats, but if you hold the dit with your thumb, it will just repeat it with that proper inter-element spacing forever. The iambic, I believe, does the repeats on both sides, so it's a little bit more like what I've made here, although I think mine's kind of a bastardization of the 2. So what this means is that in software, we want a way to look at 2 different switches that are being touched, in essence, and I'll pull up the circuit diagram in a second, and we want to base the timings or the durations of the pitch being sent based on which switch we're pressing. So let me scroll down here into, if I can find where I put that circuit diagram. I thought he was here somewhere. Oh, yeah. So let me blow this up for a second. I'll go to the original here. So this is a fritzing diagram I made, and you can see here what I'm doing is I am using a common ground between 2 switches, and then the other leg of the switches run to 2 different digital inputs on a Gemma M0. And so if we press this right switch, we're going to get the dot timing, and if we press the left switch, we'll get the dash timing. The way that we're going to do this, however, unlike building 2 switches, is with this clothespin arrangement. So let me show you that, and then we'll go ahead and build it. How about? And let me know in the chat if you've got any questions or corrections. Oh, yeah, C. Grover just mentioned there's a nod to DigiKey. So a lot of you are familiar with DigiKey as an electronics distributor and good friends of Adafruit. DigiKey is, the company is named after one of the first kits that its founder built, which was a DigiKeyer kit, and it was a Morse code transmission keyer with sort of a solid state one, a modern one where I believe it was based again on capacitive touch, so that you had I think 555 timers or some other chips built onto the board that took care of these timings depending on which thing you touched, which is pretty cool. There's a bit of DigiKey history there. So the switch that we're going to make is going to actually use a ground, a common ground, which is going to be this nail here. Let me blow this up for you. And then we're going to run our digital inputs to two sides of this clothespin. Now, clothespin is not conductive, so you could either wrap wire around it, bare wire around the two separate ends and keep them sort of insulated from each other or disconnected from each other. You could use aluminum foil, which is actually what I did when I first prototyped this. Or I'm using here some of the woven conductive fabric that we have on Adafruit, which is a really interesting fabric. So let's stop talking about this stuff and start doing it. I'm going to head over to my workbench, and we're going to take a look at some of the elements of what we're building here. Wood, not conductive, check. Thank you. You guys, you people crack me up in the chat. So the first thing let's have a look at here is our conductive fabric. I think my camera switcher might be sending me to some funny different cameras than I've been used to because of some changes I made. So let's see if I can navigate that. Okay, there's a little overhead. Let's give you a big overhead of that one and a little workshop one. Okay, so that's a Gemma. So this is this conductive fabric here, and it is woven thread. It's actually has very low resistance. If we take a look, I'm going to pull up my multimeter here and flip that around so you can see it a little better. And try to focus this. So I'm just going to take my leads and clip them to the fabric unceremoniously. We'll be using some little strips of this later. And it kind of doesn't matter where on the fabric you do. I'm going to pick the opposite corner so we know we're not cheating. And you can see here we get 0.2 of an ohm of resistance, so very, 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 very low resistance, which makes it great for our needs of building this contact switch. So what I'll do is I'm actually going to switch to that camera there where you can see a little better some of what I'm doing. And we're going to grab a clothespin. Let's see, there's a nice looking specimen. We'll take this clothespin and I'm going to grab scissors, and I don't need this multimeter now. The key to this really is some double stick tape. It sort of helps us get, oh, let me zoom this guy down, sorry. There, how's that? This double stick tape helps us get a really nice bond to the wood so it's not flaking off. If this stuff were to move over and accidentally touch the nail, that's no good. So some good double stick tape is very handy. And actually one thing you can do is lay it down before you cut this. So what I'm doing is I'm creating a piece that's going to be long enough to wrap around the outside and the inside of one of the wide legs of the clothespin. And on one side we're going to, let me switch this camera again. Is that this view? Yeah. On one side we're going to connect an alligator clip or a wire. So we want to have a little bit of space where we don't have the tape. That'll make it a little easier for us. So we can lay down that strip, and then you can see that shiny bit there. I'm going to cut that out just with some regular old scissors. And that's just about the right size width-wise for the clothespin. A little big. We could trim that if we need to. We actually don't need to. And so now I'm going to take the free end that doesn't have the tape on it, and that's going to go on the outside of the leg here. And I'm just going to wrap this over and stick that. This is easier to do before we nail the clothespin to our board. So there you go. I can leave this excess here, and you can see this is the little flap where I don't have adhesive, and that's where I'm going to connect up my wire for the switch. So let's repeat that with another bit of tape. I'm liking this conductive fabric. I've never really used it for projects. And like I say, my go-to for this was going to be aluminum foil, but that's a little bit, it's a little hard to adhere to stuff, and it looks a little janky. It will work, but we're going for a little cleaner build here. Hey, that tape didn't want to stick. You gotta press it down like you mean it. Okay, and I'll show you right now, we'll do this again later, but while it's an unobstructed view, I'll show you what we're going to do with these alligator clip leads. Oh, am I upside downing this? Let me flip this camera around, sorry. That's better. That was looking weird to me, sorry. Just like so is how we're going to end up connecting it. And the movement is going to be pretty small, so these aren't in any grave danger of peeling off our switch fabric. Okay, there's a lot of cool tricks you could do with this sort of thing. I don't know if you built like little alarms and things, contact switches with clothespins when you were a kid, but being able to like remove an electrical contact or add one with a little springy thing like this is pretty convenient. They're easy to mount to things. You can have them pull off of, you can put the contacts on the insides and then stick them over an object, and if a string pulls it off, that closes this contact and makes an alarm go off. A lot of cool stuff you can do with a simple clothespin. So let's see. Phase 2 of the operation is going to be, I'm going to take this block of wood. I'm going to lift this camera up a little, and I know I'll have to refocus it. And I think that is the magic word. When I say refocus, I'm going to check the chat just so you can warn me if anything has gone awry with audio or video. You can tell I'm still paranoid about that. Let's see. Oh, hi, Sophie. No sweeper blade this time. Right, Matambale? Sweeper blades are the best, it's true. Let's see. I just have to convince my iPad to show me the video and the chat for the video. Top chat. That's the button we're looking for. By the way, I just noticed that the YouTube has started preserving the chat. It used to just go away, but now when we get our baked-in video that you can watch later, the archived video, it is now inclusive of the chat, which is pretty cool. So don't say anything that you thought was just going to go away. Okay. So good. Looks like chat is live, and now what we're going to do is prep this. So what I've come up with is essentially this is a 1x3, 5 inches long. And by the way, if you're not familiar with this, 1x3 is a nominal measurement, the way that standard lumber sizes work. That's the size of it when it's cut, and then through drying it shrinks. And this is actually 2.5 by 3/4 of an inch. So is that right? No, 3. No, 2.5, I think. Yeah, 2.5. So that means, yes, I can go 1.25 inches over and about 1 inch up to place a little mark for a hole for the pin. And we just want to align the center point for the pivot of the pin and the nail that's going to be its contact so that everything is even. And let's see, have that measurement right? 2.5. Was I doing this in? Yeah, life's easier in millimeters. This is 6 millimeters, so I'm going to go to the 3. That's easier for me. And what did I say? About 1 inch up. These measurements, these precise measurements, are in the guide, so check that out. And now this is a special treat. I get to use these nails, which one Father's Day, my daughter gave me this little jar of nails that she got at the hardware store for me, which was super thoughtful, I thought. A little illustration of the nail, and it said on it, "Dad, you've nailed it on being an awesome father." So thank you to my daughter for these nails, and they happened to be a very particular size and shape that worked out well for this, but you could get away with pretty much any nail. These just happen to be pretty close to the right diameter for this, so there's not a lot of slop there. So this is going to go like so. Before I nail that in, though, I'm going to measure and mark for the nail that will be our contact. So it's going to be about there. You could do that as far as height, that's fine, but you do want to measure the same distance across the board. Where we go, 3 millimeters there. You can adjust this a little if needed later, but the idea is we're going to use rubber bands that are sort of providing counterforce, which will keep the rubber band steady in the middle until we go and hit it. All right, so right there should be good. And then the other one we're going to put through our clothespin like so. Watch your thumbs. Sometimes it's easier to grab these with a pliers if you need to. You don't have to pound it in too far. It's okay if it has a little movement there. What you don't want to do is get it so that it's stuck, because this does need to move. Okay. So that's looking pretty good. This nail here can go in just a little further, and a little straighter would be good. Okay. So that's how we're going to key it. Now, this is a really large movement for if you're looking at how some of these paddle keyers work. It's tiny little movements that people do. So this isn't going to win any awards for speed in Morse, but I think it's a good introduction to it. So next step we're going to do is to essentially provide a pulling force in both directions with some rubber bands. So I've got a couple of these little rubber bands that were part of this craze for making jewelry called rainbow loom. We have tons of these still in our house, and they're actually pretty good. I was thinking at first like dental bands, if anyone in your house has braces, but these are a little longer, and that's probably good in this case. We don't want it to be too tight. You could use very small bands and hammer in a couple of extra nails to provide this pulling force, but what I came up with this works well and reduces the number of nails that you need, which is we're simply going to wrap around one leg and twist it, and then just go around the end of the wood like so. And so you can see now it has pulled in this direction. And what we want to do is use another band that will pull a little in that direction, and then we'll have sort of a spring back release, so when you're not touching the keyer paddle, it is not touching the nail. So let's go around the other one one more time, like so. And what you'll see is it's favoring one side a little bit. Actually, that's pretty good, but if you do find that you need to adjust it, just pulling and tugging in one direction or another on the band so that it's providing equal force. If it's a little tighter on one side, it's going to pull a little more on that side. So there you go. We have a pretty nice little momentary switch now. And you can use this for all sorts of projects, not just for your Morse code paddle. Nice shiny fabric. Okay, so now onto the Gemma. Let's see, where did I put it? I just programmed it. So actually, you know what we're going to do? We're going to take a break from that. We're going to head over to my workstation, and let me bring up for you, hi, it's me. I'm going to add one more window with, I was going to use the Arduino. Oh, you know what I'll do? Let me just pull up the browser again. Where'd that one go? Because I want to show you the project that led to this, which was the Phil Burgess DMA and DAC project. So let's go back here, and I've linked to it in my guide at the beginning, I think. Let's see. So this guide right here, Circuit Playground Express and other @SamD21 boards, DAC hack. He's got two of them actually. There's one where he's broadcasting VGA graphics to an old monitor, and in the other he's doing AM radio transmission. So just looking at this overview, these are the kind of two key things. This M0 chip, the @SamD chip that we have on our Circuit Playground Express, the Gemma M0, the Trinket M0, the Feather M0 Express, the Metro M0 Express. Those chips all have these two really cool features, one of which is there is a true analog output. So, you know, on microcontrollers, you usually got a few of these pins called A something or other. And what happens typically is that we send a varying voltage level. So if we want to dim an LED, or change the speed of a small motor, we can tell that analog pin to output, or write, analog write, if you're using Arduino terminology, a varying level between usually 0 and 3.3 volts, or 0 and 5 volts, depending on the chip. But on our M0s, these are running at 3.3 volts, so we can go from 0 to 3. In the past, that was a lie. That was actually a digital square wave, or a pulse width modulation, that pretended to be an analog output by turning on and off essentially a digital signal very fast. The M0 chip has a real digital to analog converter, so we're able to send a real smooth wave out. So this is important for being able to modulate that amplitude of the wave to get our radio output. And then to be able to do some of this fast, Phil's using this direct memory access, this DMA, which essentially shortcuts the CPU talking to the peripheral, and this was invented for hard drive access and things that need to be very fast with minimal overhead. So the fact that we can do both of these things on this chip allows us to, and let me see, I think he's got a nice diagram of the wave on here. Whoop, where'd he go? Transmitting AM radio. Allows us to approximate what an AM signal does. So if you look at the sine wave here, the sine wave would be like a held tone, boo, and that held tone is created by oscillating the frequency, or the amplitude rather, the strength of this fixed frequency up and down. So AM is amplitude modulation. So the essentially height or strength of that gain of the wave can go down and up to create different sounds, different pitches. If we look at the AM signal here, it looks an awful lot like this, this waveform. So the fact that we can essentially vary the voltage on that A0 chip fast enough to approximate the signal and the sound that we're trying to output is bananas. It's really cool, and it allows us to do radio. So if you check out this guide from Phil, you will very quickly be able to download a couple of special libraries, upload some sample code, and play songs at a very close distance. This is not a powerful transmitter. You're inches away from the antenna, but you're still across the air able to send the signals. So what we're going to do in the case of the Morse code, let me bring up my Arduino window where I've got the sketch. Oh, actually, sorry, I've got it in my web guide, so that'll be the place to check it. Let's see. I just made this guide, and I can't remember where I put the Arduino sketch in it, but it is here somewhere. Whoop, not there. Is it in the what is Morse code? I think it's at the bottom of this. Yeah, here we go. So this is it. It's a pretty short sketch. All we are doing is creating this instance of the radio from the AM radio library that Phil made, looking at two different buttons. On the Gemma, I've picked pin 2 and pin 0 to be my digital inputs, because the other remaining pin is actually our analog out, which we're going to use to send essentially our radiate our signal using an antenna. And then I am creating some little constant variables that we'll refer to later. So one is the frequency of the pitch, the sound. And that is, I chose 680 hertz, which is within the range of what's typically broadcast when you're doing audible Morse code. The duration of my dot, I said it was 100 milliseconds. And then the other two things that I'm using in here, since we're not transmitting words automatically, just elements, I only need to define the length of a dot, the length of a dash, which is the dot times 3, and the length of the gap, or the pause, or the rest between them, which is the dot. And then from here, this looks probably very familiar to you. The setup is saying I'm using some of these pins for inputs and some for outputs. I'd set the LED pin to output so that the red light blinks when we key it. We instantiate the radio and tell it what frequency. So this is actually at 540 megahertz, which is what we're going to tune our radio into. It works best at the lower end of the AM spectrum, but you can change this. If you're getting interference with a station, you can adjust that number to something that's tunable on your AM radio. And then from here, it's simply watching those buttons to say, what are we doing? Normally, these pins, since we're using them as an input pull-up, will be high. They'll have voltage on them. When we close the contact with our clothespin left or right, the signal will drop to low, and that will turn on our LED and beep our beep. And then we have that going in two directions. And I'm putting a little delay in there to keep things from tripping over themselves. So that's what is going on. And then remember I showed the diagram here. Here's a version of it when I talk about the AM antenna. So let's pull this up. Go to the original. So that's what we're going to refer to when we build this. So I'm going to head back over to the workbench and let's put this thing together. And let me know if you have thoughts or comments or questions. We'll talk about antennas. That's an interesting topic. We'll get into that in a second. So here we have a battery pack. I have a Gemma that I lost. Where the heck is that thing? You saw me move it earlier. There it is. Moved off to the side. So we have, am I in this camera? I am. We have our little Gemma, and get a little closer here while we clip things and make that the big camera. There we go. So I'm going to cheat and look at the one I built that I have sitting over here before so I don't screw something up live on air. So what we have are going to be, actually, let's do this in reverse order because I want to do one part of this a little differently. Let's make the antenna before I create the connections here. So the antenna we're going to make from some of this enamel. Oh, did I switch the cameras again? Sorry about that. I thought we were in the big view. There we are. We're going to use this enamel magnet wire, enamel-coated magnet wire. So it's a very thin copper wire. And antenna for the AM radio, there are formulas you can do for creating an antenna that is 1/2 the length of a wave or 1/4 of the length of the wave. These are impractically long for what we're doing with this little radio. You could coil this wire around a little stick and get to that length, which would be, I don't know, many feet long, hundreds of feet long. I'm not quite sure. I don't know the formula. But I'm sure someone in the chat, if you know, how long this antenna would need to be for the needs we have, that'd be interesting. Oh, someone says kilohertz. Sorry, yes, kilohertz, not megahertz. Whoops, thank you. I'll correct that. I think I wrote that wrong in the guide. And you saw it there, right? That number was 540,000. So what we're going to do is we're actually just going to use a moderately long length, so about 40 inches or so. Whoops, we'll do. I just whacked a camera there. You can use a ruler or a tape measure if you want to get an exact length, but since we're really using this pretty close and we're not making an ideal antenna, we're not going to get super precise with this. So now we have our magnet wire, and if I hold that in the light just right, you can see it glinting there. Let me see how much closer I can get with this camera and still focus so you can see what I'm about to do. So let's see how that focus worked out. Good, bad? Yeah, I think so. Oh, yeah. Let's try one more time with my finger in it. Sometimes these focus things work better when there's a body part in view or something higher contrast. There we go. So this wire has enamel coating on it, which means we won't make a connection to it to our board. I'm just trimming the end off there. So there's a couple ways that we can remove that. One is just to take a hobby knife or some scissors and scrape away. Kind of have to roll this a little bit. Scrape away that enamel, and then we can test it with a multimeter to see if we did it. It doesn't hurt to get a nice bit scraped off there so that we have a better chance of getting the connection. So we'll test that in a second, but that's one way of doing it. The other thing we can do is use a lighter and burn off the enamel, and that's kind of the more fun way. And you can tell based on last week's show that I was having a lot of fun setting things on fire. So let's see I'm going to try to not set the camera on fire, so I'm going to switch views. You go to that view there. That camera's further away with a longer lens, so it won't be quite as close up for you. But, so if I can get that to focus, I'll do it. Have that right over this piece of black. There we go. So you can see copper wire. I'm going to just cook that off and make sure we don't actually stress the wire out too much. It'll get a little darker, but that should be good. So before we connect that to the Gemma, I'm going to grab, again, my multimeter, and we can just go into continuity mode now. And again, these wires are so tiny that we want to be careful not to break them just pinching them in the little grippers on the multimeter if you have those. Okay, so we seem to have grabbed a part, and no. Let me just make sure we are in continuity mode. All right, I'm going to try scraping on this end where I burned and see if that does a little better. Now, another thing about the antenna, if you look at basic tutorials on AM transmission and then look at more advanced ones. In basic tutorials, there's usually just a short length of wire, and you can be very close to your radio, and that works well. If you look into more advanced antenna designs, there are dipole antennas where we're running one end to the positive signal, one end to the inverse of the signal. Some antennas will go to ground. There's a lot there, and I'm not a ham radio person or a radio person in general, so I don't know a lot about radio design, but it's not straightforward. What I found with this project is it's at least interesting before you get too caught up in looking at the formulas to just try things and see what you get. I'm sorry, you're not seeing me scrape that off. And what I found with this is actually it does tend to work better if you ground one end of this antenna. I don't know why. Some antennas, they say put it on a big ground plane and that'll help. But again, for some radio fluent people, there we go. So it seems to be scraped off pretty well across a good section of it. So we're going to find through some experimentation how to get our signal transmitting well. So let me switch these cameras around again. So we're in this little down shooter. And what I'm going to do now is to connect one end. Actually, we'll do both. We're going to connect both ends, and what we're going to use is some little screws. So what I found is with the Gemma and the Circuit Playground, you can make some pretty decent connections with M3 screws. So this is an 8mm long M3 screw. And so what I'll do is I'm going to try to wrap one end of the copper wire around the screw and then screw it down in to A0, which is this guy here. Let me flip him. Can you see that? I think you can. So he's also labeled D1, but this little squiggle there, that's important. That means this is the analog, the true analog with the digital analog converter. So I can take this. I'm going to put on glasses so I can see. Where are they? Oh, sorry, that was my mic. I just was whacking. I often have my glasses hanging off the front of my shirt there, so it's an instinct to grab that. Ooh, these are dirty. Okay, so what I'm going to do is take this end and just like you'd imagine, try to pinch it around my finger, and we want to get a good connection to the screw. These are conductive screws. You want to check that if this is how you plan to use them. And now I'm going to send that through the A0 pad there. Let me refocus this, sorry. And then I'm going to take a nut. And as long as you get the right size screw, I mean, most M3 screws are going to have a very close tolerance for the width. I think it's 6mm or something for the width of the the head, but you don't want to get so big that you start bridging to other parts. We're really close to, I think that's a leg on this switch here, so you don't want to start bridging things. So now we're in the A0 with one side of the antenna. And why don't we, I guess we can just go ahead and connect this up. I think when you try this at home, especially if you're using alligator clips, which is the other way I've done this, you can experiment a bit. I'm just going to try going straight to this loop. And I have seen other small AM devices, sort of DIY devices that have a small wire that is running to ground for AM. So I think there's something there, but it's an area I am ignorant in mostly, and I need to explore that more. So let's see if we can get that through on ground. The other thing with these antennas is you are a pretty decent ground source yourself. So if you can hold or touch your antenna, very often you'll get an even better signal. That's not always practical to make yourself part of the antenna, but when it is, it works pretty well. Oh, I started to loop up and away a bit there. I'm going to pull that tight, and I'm actually going to use a little driver. Is that the right size driver? It is not. Do I have the right size driver? Is an important question here. Oh, yeah. No? Yeah. Yeah. I think what I'm doing is I threaded the wire onto the screw a bit, so if I don't break it, that's probably a good thing. It means it's in there pretty well. Okay. And let's see, I might be able to, I'm not sure if the innards of the chip will allow this, but there's a chance I can check continuity of those two screws. I'm not certain, I haven't tried it this way. It is not doing that, so we'll see. I gotta tighten that. Maybe. Okay, I'm nervous that the end of this, I think the part of the wire that is actually under the screw is not stripped of the insulation. So it might be good to strip more than I did there. I'm just going to tuck that under a little more. That's the stripped end. You could also use a regular stranded wire. There we go. Seems like that's connected. Okay. Either way, as long as we have a connection from that to antenna to A0, we're going to get something. Okay, so now let's swap cameras out again. Oh, was I not under this one? I'm so sorry. When did that switch? That. Oh, I guess I was. I just confused myself because this one is zoomed in enough. So that's probably a good, I'll zoom out a little bit. There we go. So now we're going to make our connections. So what we have, you could use foam tape on this or a rubber band. I think if I can grab some foam tape, I'll do that because that'll stick well. So some double stick foam tape on the battery box and connect that to, adhere that to the wood. Get this out of here now. Like so, and we've got our on-off switch there. I'll turn that off for now. And now we can connect, we'll even put, yeah, let's do the, I'm going to leave this floating free for now, and then maybe we'll rubber band it down. Will that work well? That might work well. That might move, we'll see. I zoom in a little for you more. Okay, so connections that we have now are going to be the D2 pad is going to go to, get this alligator clip. You could use any kind of wire you want here. It's you could use, again, some screws and wire, but this is pretty convenient if you've got some alligator clips. So this is going to go to the right contact here, just clips to that little free end. You know what, I'm going to double stick my Gemma down a little bit because that's going to be sliding around, which will be annoying while I'm trying to show this. Oops. Here's a trick for you with double stick tape. If you need to, you can double it up to get thicker. This is some pretty thin double stick tape, so you can hook together any height that you want by just sticking multiple pieces together. This is kind of thin, but there we go. I'm just going to set the front of it there. So now we can go from our D1, our D0, which is the other side we're going to be reading for the DIT. I'm going to go across. Let me move this antenna out of here. Nice thing is this is enamel coated, so it's not going to bridge contacts. It's insulated. And now what we want to do is run from ground to this center nail, and that's what's going to close that contact. So I'm just, again, going to use an alligator clip. This is kind of a long one, but I'm going to go around the nail, avoiding getting in the way of the paddles when they're at rest. Oh, I'm going to trim that one. That one piece is going to come close to contacting. I'm going to get some smaller scissors out for this. I have this little Swiss Army knife money clip thing that has some nice small scissors on it for these operations. I don't have any good small scissors in the shop. So I'm just going to trim that excess conductive fabric away so I'm not touching the clip. There we go. So that ground I can now connect to the little screw here, which acts as kind of a nice little post. And all that's left to do, a couple things. We're going to power it on. And let's see. I said we're going to power it on, and it did not power on. What's going on here? Is my Gemma off? Yeah. The Gemma has its own power switch, which I forget sometimes. Most of our microcontrollers don't, and this one, it does. Okay, so now what we should see is when I da, we get that long. It actually doesn't turn off long enough to see with this LED, but this one you can see blinking a little bit. Let me go to this view. Get in good and close. Hey, it didn't focus on that wire. That's good. So there you can see my LED kind of blinking there. So that's the DIT and DA. DIT with a thumb, DA with a finger. So now what I'm going to do is fire up a little AM radio I've got. And so you'll notice we're not making any sounds audibly through a speaker or anything like that. So anything we hear will be this little AM radio. And I'm going to try to fit that into the camera view a bit so you can see it. And so there you can see, let me turn that down, I'm tuning that into the 540. So there's the sweet spot. And let's switch cameras over. Oh, I switched to the wrong camera. What happened to that view? Oh, I'm zoomed way in on this one. Sorry. There we go. Now, we're not going to get a ton of range. You can see as I move this away, it gets weaker. stronger as I get very close. So I've gotten, with this kind of antenna, if you angle things well, I've gotten probably 4 or 5 feet away sometimes and still had a decent signal. Here we're getting a couple feet. So let's try moving. That's kind of weak right there. I'm going to try moving this antenna around. And even as you move your own arm around, we'll reorient this. That's a bad spot. There's a good spot. So kind of vertical. So the orientation, let me turn that off. The orientation of it can make a big difference for the waves radiating in the same direction that the receiving antenna wants to pick it up. So you can try moving around both the transmitter and the receiver. So that's the basics of the Morse code paddle keyer, using the Gemma M0 as our transmitter, despite the fact that it has no radio. I thought this was a really fun trick, kind of amazing that it works, that without a sort of explicit radio on there, you can make a radio just by forcing it to ping those values very quickly, quickly enough for it to pick up. Check out Phil's article if you want more information on how that works under the hood. And let's see, is there anything I forgot? Let me do some housekeeping here. One thing I wanted to do, let me move over here, is, oh, I'm going to check the, before I move, let me check the chat. So let's see. Boost the power, Scotty. So some people have AM radios in their cars. Yeah, you don't have them around as much anymore. Oh, someone said when you're stripping magnet wire, John Schaffstall says, use emery cloth. That's smart. So you burn off the enamel, and then that soot might be getting in the way, which makes total sense. So use a little emery cloth. Emery cloth keeps coming up. It came up in lockpick making last week. I got to get some emery cloth. I don't have any. I just have the paper. But that's a great idea, John. Thank you. So that'll help you strip the wire. Yeah, magnet wire is a lot of fun. You can coil it and make little magnets, electromagnets and things with it. Motors, electromagnetic motors. Pretty cool. So let's head over here for some housekeeping. One thing is, I don't want to forget, we have a coupon code this week, or today only, in fact, for tuning in to the workshop show. You can get 10% off of your order at Amazon, not at Amazon. That'd be kind of cool if I had that power. Take two. You can get 10% off of your order at Adafruit. That's the one. On anything except for gift certificates. So head on over, use the coupon code PADDLE, P-A-D-D-L-E. I don't know if it's case sensitive, but I did it in all caps, so try it in all caps. Should work that way. And that will be effective until midnight tonight, and you'll be able to get your order. I know that they've been having some issues with weather over on that east coast of ours. But I believe one of my orders, I placed an order, I think yesterday, and got a message that the shipping might be delayed a little bit. So don't let that stop you, though. Maybe that weather has let up a bit. Let's see. Other housekeeping things. Let's head over to both YouTube and Discord chats. Let's see. Oh, and there's the Facebook chat. There's a couple people in Facebook chat. Hello, Facebook people. I wish I had time to check them all, but I know that we've got some good conversations probably in places that we don't even see them. Let's see. Let me restore chat. Where's the chat? Pop out chat for YouTube. Yeah, so someone asked about, check into the FCC regulations. You are, based on the power of your transmission, you have to be careful. This thing is not powerful enough. It goes just a few feet, so you're not going to be in any danger, I think, of running into the need for licensing your AM Morse transmitter. And thank you, Matambale, for mentioning that. Oh, and so C. Grover says, you may want to try a small series capacitor in the antenna circuit so the analog output isn't shorted to ground, DC-wise. Checking the data sheet now to see what it can tolerate. Yeah, you know what? We've got a minute here. I just want to go, let me head back over there for a second and try I'm going to just cut that antenna from ground and see, because I don't want to move anything, but I want to see if we notice a change in it or if I'm just imagining things. So let's head back over here for a second and see if I'm... Let's turn the radio back on. Ooh, lots of feedback. Okay, I can hear it well enough there. And I'm going to just use those little scissors to cut that ground connection. Yeah, it's the same now. Yeah, you know, it's antenna madness. I'm going to hold the end. I'm going to become part of the antenna. Let's see if that does anything. So here's the signal now. I'll have to scrape that. Let's Oops, sorry, camera. You can see as I rotate it, we get different. That's just getting a lot closer and further. Okay, yeah, so there's a chance that helps, trying the ground thing, but thanks C. Grover for checking out on the capacitor thing. Like I said, I don't have tons of knowledge about antenna design, and it's a fairly advanced and sophisticated topic, at least for me, so I think there's a lot you can do to try to improve that. Oh, this is way, way low. John was just joshing. Yes, Metabole, it is very, very low. You're not going to run into problems with this, I promise. But if you do start getting interested in the antenna design and boosting your power, be careful about transmitting radio. Let's see. Well, thank you guys so much for tuning in. I think that's all. Check my notes. I wanted to make sure that you saw the coupon code there, paddle. I forgot to mention that, I think, last week or the week before, what your coupon code was. And we are in full AdaBox mode, gearing up, putting guides up. This is AdaBox 7 coming up. There'll be an unboxing on April 3rd. So please mark that on your calendar if you want to see the live unboxing and all of the projects we have for AdaBox 7. So I hope you enjoyed the Morse code keyer and AM transmitter with Gemma. And I'm John Park. This is John Park's workshop for Adafruit. Thank you, and I will see you next week. Goodbye.